So question 4 gives us the equation dy dx equals 6x squared minus x squared times y, and it gives us an initial condition of f of negative 1 equals 2. And part A asks us to use Euler's method with two steps of equal size starting at x equals negative 1 to approximate f of 0. So what this means starting off is that our dx has to be 0.5, because in order to have two steps, in order to go from negative 1 to 0.5 and then from 0.5 to 0, we have to have a dx, or a change of x, of 0.5. So we go from negative 1 to negative 0.5 to 0. So as you can see that in the table right now, and we have a dy dx of 4 for the initial condition, because when you plug in the values into the equation, that's what you get. And now in order to find your dy, you have to multiply your dy dx by your dx in order to single out the dy. So what we can do is multiply 4 by 0.5, as our dx is 0.5, and what you get is 2. So what you do now is that you now add that 2 to the initial condition. So now your next y value for negative 0.5 is 4. So now you do the whole process again. You plug in 4 and negative 0.5 into the dy dx equation, and once you do that, you get a dy dx of 0.5. And once you have that, now you can find your dy. As we do it, we multiply, and then you get 0.25, and then you just add 0.25 to 4, and your final answer should be 4.25. So the most important part of this question is realizing that you have to use two steps of equal size, meaning that your dx has to be 0.5, and it also has to be a positive number, since you're going from negative 1 to 0. So on to part B. So part B uses the same initial condition, and it gives us the second derivative at that point as negative 12. And it asks to find the second degree Taylor polynomial of f about x equals negative 1. So the way we do this is, first we should write out the equation for Taylor polynomial, and that is Pn of x is equal to f of c, and in this case your c is negative 1 since it's the center. So f of c plus f prime of c times x minus c plus f double prime of c times x minus c squared over 2 factorial. And I'm going to stop there because we only need the second degree, and the second degree is the term with 2 factorial. So now what we need to do is plug in negative 1 for c. So it would be p2 of x, and the n is replaced by 2 since you're doing the second degree. So it's f of negative 1 plus f prime of negative 1 times x plus 1 plus f double prime of negative 1 times x plus 1 squared over 2 factorial. So now you can plug in with the values that we got from part A and the values that they give you. So now p2 of x would equal 2, which is from the initial condition, plus 4, which we got from the past question. So it's 4 times x plus 1 minus 12, which is from the value they gave us in this problem, times x plus 1 squared over 2 factorial. And in order to simplify this, we can write this whole thing as 2 plus 4 times x plus 1 minus 6 times x plus 1 squared. And the reason we can write it as negative 6 in this case is because 2 factorial becomes 2 times 1. And 2 times 1 is just 2. So you can easily just divide negative 12 by 2, which would get you negative 6. And that would be your final answer. And the most important part of this problem is knowing that what the second degree polynomial means and knowing the equation of the Taylor polynomial. So on to part C. And part C asks us to find the particular solution to y equals f of x given the differential equation with the initial condition f of -1 equals 2. So we have to realize that this part C is a separation of variables question where you have your dy on one side and your dx on the other. So in order to be able to get that, we have to essentially transform the equation that we're given into a much simpler equation to work with. So the way we do that is by essentially factoring out x squared from the equation. So you would get x squared times 6 minus y, and from here you can get dy on one side and dx on the other. And once you get this, you should have dy over 6 minus y equals x squared times dx. And once you have this, we can now integrate and find the antiderivatives. And we can integrate, and once we integrate, we get negative ln of 6 minus y is equal to 1/3 x cubed plus c. And the reason we only have c on one side is because the c is a constant that constantly changes, so you only need it on one side. And now we can use our initial condition, which is -1, 2, and we can use it to find the c. So once we plug in -1 for x and 2 for y, you get negative ln of 4 is equal to -1/3 plus c. And now from there, just find c, simple algebra, just add 1/3 on both sides, and you get your c to be 1/3 minus ln of 4. And once we have this, now we can go on to solving for y, because now we now have c. So what we need to do is now plug back into the original equation our antiderivative. So we now need to plug in 1/3 minus ln of 4 into the equation that we had before. So that would be negative ln of 6 minus y is equal to 1/3 x cubed plus 1/3 minus ln of 4. And you see that we have a negative in front of the negative ln of 6 minus y, so all we just do is multiply it so that the ln could be positive. So now you have the negative to the right side, so it would become negative 1/3 x cubed minus 1/3 minus ln of 4. So now we can now put e to the power of each of these values. So when you put e and have a power of natural log, it cancels out the natural log and you're left with whatever is inside. And that's what we're trying to do here. We're trying to get rid of the natural log. And on the right side, when you do it, since when you raise something to an exponent, you add the exponent. So now we have e to the negative 1/3 x squared times e to the negative 1/3 times e to the 4. And once we have that, we can get 6 minus y is equal to 4 e to the negative 1/3 x cubed minus 1/3. And now we just have to do simple algebra to find our final answer, which should be y equals 6 minus 4e to the negative 1/3 x cubed minus 1/3. And that would give you your final answer. So overall, to recap, the most important part of this problem is to realize that you have to do separation of variables and you have to find the c, and also you have to make sure that your antiderivatives are correct, and you have to know how to get rid of the natural log.